Hi and welcome to this video. Today we're going to look at the relationship between hybridization and bond strength. In other videos we've looked at other factors such as resonance, so be sure to check those out. So in this problem here we're going to rank the CH bonds from strongest to weakest. Now looking at the bond order is not going to help us because they are all single bonds. So instead we're going to look at the orbitals involved in the bond. For hydrogen, it will always be a 1s orbital, whereas for carbon, it will depend on its hybridization. So the hybridization for the alkane is sp3, for the alkene, sp2, and for the alkyne, sp. And what we're going to focus on here is the s character of the hybrid orbital, which refers to how much the hybrid orbital looks like the s orbital. So if we recall, the s orbital is spherical, whereas the p orbital looks like a peanut and is a little bit more elongated. So if an orbital has more s character, like in the alkyne, which has 50% s character, the orbital looks more round, more like an s. Whereas if the hybrid orbital has less s character, 25% for the sp3 hybrid orbital, it will look more like a p orbital, more elongated and less round. And this has a direct impact in the bond length. So more s character is going to be a shorter bond, whereas less s character is going to be a longer bond. And we know that a shorter bond is a stronger bond, and a longer bond is a weaker bond. So based on that information, the alkyne has the strongest CH bond, and the alkane has the weakest. So looking at the hybridization of the atoms in the bond is also useful for carbon-carbon bonds. So in this problem, we're going to look at which of the three bonds is the longest or the weakest. And they all appear to be single bonds at first glance. Now B actually has a bond order of 1.5, as we discussed in a previous video. So it is actually the shortest and the strongest bond. So we're between A and C. They're both single bonds, so we can solve this problem by looking at the hybridization of the carbons in the bond. For A, we've got one sp3 carbon and one sp2 carbon. And for C, both are sp3 carbons. Less s character means longer and weaker bonds, so bond C is the longest bond. Let's look at one more problem. We're going to rank 4 carbon-carbon bonds from shortest to longest or strongest to weakest. Again, all single bonds here. So we're just going to list the hybridizations. For A, we've got sp2, sp3. B, we've got sp, sp. C, we've got sp, sp3. And D is sp3, sp3. So the shortest will have the most s character, so that would be B, followed by C, followed by A, and finally D. And finally, here is one more problem that I will leave for you to think about, so let me know in the comments what you think the correct answer is. If you found this video helpful, please like and subscribe, and be sure to check out the other videos on bond strength.